So today we're going to talk about constructing or finding a sample size for a specific margin of error. So how do we do that? So first thing we're going to do here though is go through a quick review of how to find our confidence intervals. So our first one here says crop researchers plant 15 plots with a new variety of corn. The yield in bushels per acre are, and here's a listing of that. So construct a 90% confidence interval for the population mean yield. Interpret that and then identify the margin of error. So to start that out, what we need to do is to take this information and enter it into a list. So to do that, you go to stat, you go to stat, into edit, and then you can enter them all in. I've done that previously, so I'll move on from here. We go then back to stat, go over the tests, and we're going to run a t interval. So we go into t interval. And we have two choices. Stats is when you can enter, when you know the mean, the sample standard deviation, the sample size. Okay, in this case though we have the data, so we're going to use the data. We put whichever list, we just put that data in. We keep our frequency at 1. We put our confidence level at what we want. So in this case we want 90%, so we put 0.9. And if we calculate it here, we see our confidence interval would be 118.22 to 129.38. So interpreting that, we would say that we're 90% confident that the yields in bushel per acre, the mean yields per bushel, mean yields in bushels per acre is going to be between 118.22 and 129.38. So what would we do then in the second one? Construct, here, first off, we want to identify the margin of error. So to identify the margin of error here, we take 129.38 minus 118.22 and divide that by 2. Remember also, we can take that, our equation that we have here, and we can find our margin of error by using this part of the equation. So I'm just going to copy that and bring it down here. I'm going to actually paste it here because this is the part where we're going to discuss it. Okay, so we can identify our margin of error. So like I mentioned, one of the things we could do here for that is take 129.38 minus 118.22, and I think the minus sign is the problem there. We get 11.16. If we divide that by 2, we get 5.58, so it would be plus or minus 5.58. So to construct a 99% confidence interval and do the same thing here, the only thing we'll change, we'll run the same test, and the information is the same, so we don't have to change that. The only thing we'll change is our confidence level. Now this should be a larger interval, and the reason it's larger is because we want to be more confident in our answer. So if we are want to be more confident, we would spread that interval out. So here you can see it's 114.38 to 133.22, which is a larger interval. So if we take a look at that, we take 133.22 minus 114.38, we get 18.84. If we divide that by 2, then you can see we do get a larger margin of error of 9.42. So once again, we could say here that we're 99% confident that the yield in bushels per acre in the population will be between 133.22 and 114.38. Okay. Now, if we're looking at our margin of error, the formula that we could use here is plus or minus our critical value times the quantity of our sample standard deviation divided by the square root of n, so divided by the square root of the sample size. So if we take that equation and manipulate it to solve for our sample size, this is what we'll have here. We'll have n is equal to our critical value times our sample standard deviation divided by our margin of error. All that then is squared. So this is what the formula we're going to use here to solve for our sample size. All right, so if we're given a specific margin of error that we want, we're going to then manipulate, or we're going to use this equation to find, well, what sample size do we need to obtain that specific margin of error. So we have a cheese processing company wants to estimate the mean cholesterol content of all 1 ounce servings of cheese. The estimate must be within 0.5 milligrams of the population mean. Determine the minimum required sample space to construct a 95% confidence interval for the population mean. Assume the population standard deviation is 2.8 milligrams. So we now have to identify these different parts here. We have our sample standard deviation. We have, we want our estimate to be 0.5 milligrams from the population mean. We just need to find, well, what's our critical. So critical values are actually going to be decided much like they were in the last chapter for what we're going to use for these different entries. Now, let me just get back here. Okay, so if it's a 95% confidence interval, we want to use the same level of confidence. So we have 95%. Here it says 1.96. Remember, we've been using 2 a lot, so we'll just use 2 here. So when we're entering this in here, let me just copy this down here. All right, so for our critical value, since it's 95%, we're going to replace that here with 2. Our standard deviation we have is 2.8, so it's times 2.8. Our margin of error we want is 0.5, so 0.5. So we just go about our math here then. We take 2 times 2.8. Whoops. So we take, once again, 2. We've got a lot going on here. 2 times 2.8. And we get 5.6 if we divide that by 0.5. We can get 11.2. Now if we square that value, we get 125.44. So that's our sample size that we need. 125.44 equals 125.44. But remember, with sample sizes, we always have to round up. So we want to round this up to 126 for our population. Okay. I want you to try the same thing here for letter B and then move on to the homework. Remember, the only difference here is here we have a 99% confidence interval. So now instead of 2, we're going to change that critical value here. Okay, so you might want to look back to your chapter 6 notes to remember those critical values based off a level of confidence. Remember, that's on the first page of your notes, so you can certainly pull it from there. Okay, once you're done, once again, complete the homework on the next page, and hopefully I'll see you soon.